Greetings, folks, and welcome to the Electromaker Show. This is your midweek roundup of all things Maker and embedded and lovely. Now, this week we have so many things to get through. We have retro computers emulated on retro computers. We have Linux on RISC-V emulations within graphics cards. We're announcing the winner of the Thingy 91 competition, along with funding website things and a bunch of cool projects. Ooh, and a new Arduino competition. So, with all that to get through, let's get on with the show. We're starting the show with a retro computing project. Now, the Commodore 64 was based heavily on 8-bit Atari computers, or was that the other way round? I'm sure retro computer people are shouting at the screen right now and cursing my name. However, it has taken this long for one to be emulated on the other, and that's what this first project has done. Now, I say emulation, that's the wrong word for this. This is the Commodore 64 kernel that has been compiled to work on an 8-bit Atari computer, and it does work. You can use BASIC, but that's about it right now. There's no other I.O., just the keyboard and the screen work, although you can blitz to the screen much faster than you could with the original Commodore 64, apparently. This is according to a comment that the original maker left here. So, for example, color text is not possible, but you can access the full range of the GTIA's 128 colors in other ways. This cycles the background in a way that's impossible on a C64, so I'm not sure if it's actually faster or not. It's a fantastic project. It's a fascinating project as well. I'll link this Hackaday article because, as well as the original Reddit post, which is this one here, which doesn't have as much information, there is a link to the GitHub page as well. And this is where all the good stuff is. There's a number of dependencies, and I don't have a Commodore 64 or an 8-bit Atari computer, so I won't be doing this myself. But even so, the GitHub page is sort of interesting. The author has mentioned that they may do a long-form write-up of it of themselves or a YouTube video, and I very much look forward to that. But for now, I will leave a link to this in the description of the video. Now, completely DIY smart home projects are a cool thing in and of themselves, but to make it look like a finished product is incredibly difficult, and I think this project gets pretty close to it. This is a project from Engineering Dads on the Electromaker website, and this is an auto-filling smart humidifier, which looks like Charizard, the Pokemon. And it's a fantastic looking thing. Look at this. This is a fully 3D printed and then painted body, and most of the electronics fit inside it. And it has LEDs for eyes, and that's without even getting into how this thing works. So just before looking at the project itself, I wanted to quickly show you this thing in action. So you can see this is a mister and or a humidifier, and the mist is coming out of Charizard's face. And this is, as I mentioned, a completely 3D printed Charizard. This is a 3D printed box for some of the electronics at the back. And while there's a few wires sticking about the place, for the most part, this is a pretty clean build. So this circuit diagram shows you roughly how it all fits together. So you have power coming in over here and a couple of indicator LEDs. This motor is actually a peristaltic pump, and that pumps more water into the device when it needs it. There is a humidity sensor here, so that if the humidity in the room drops below a certain value, the mister will turn on automatically, which is a very nice touch. And the Arduino Uno is running it, but it does also have an ESP8266 here. And then finally, this is the interesting part. The Grove Atomizer, which is a little board which works using Grove connectors. It's Seed Studio's Grove system. That, along with just a transducer, will produce water vapor, will produce the mist that you get in misting devices. It's something I've never actually played with, but it's a really interesting idea, DIY misting, something that we'll come back to, I'm sure, in the future. But it's just a really interesting build. The other thing that I really like about this is the use of Blink. Now, Blink is an IoT service, and let's see if I can find an image of it. Yes, here. This is an IoT service which is free to try. It's a service that is an app that you put on your phone, and you can drag and drop elements like buttons and sliders, and then you can quite easily implement them in code because the Blink library is fairly easy to work with. And control things over the network. You can either use their cloud service and just ping to the Blink cloud and back, or you can set up your own local Blink cloud on a Raspberry Pi. Really cool little service, BLYNK, not BLINK. But yeah, I will link this article in the description. It is a very thorough run-through of how this entire project works and fits together. And as I mentioned before, it takes some real skill to make a fully from-the-ground-up DIY smart home project that not only works well, but looks pretty good as well. So congratulations, this is a great project. Moving on now to NerdForge, who surprisingly has never been on our show before, which is very strange considering she is a maker in two senses of the word. Some of the electronics projects she has made are fantastic, including an animated LED mask last year, for obvious reasons, and a 1 kilowatt laser. She made a mini fridge some years ago that completely took the internet by storm, like a desktop fridge that actually worked. But she also makes more craft maker stuff, if that's even a term. She makes these wonderful little dioramas, and this one is especially special because it combines a lot of different things. This is models that she has made along with 3D printing, resin 3D printing, and then casting them all into resin. The idea being that you end up with these perfect little dioramas in perfectly clear resin, a little bit like the opposite of a snow globe, because nothing inside it can ever move again. It is a block of resin with a beautiful little scene inside. So the video, as usual, goes through entirely how it works, what did work, what didn't work, and what might work in the future. And I'm not going to show you the finished product. You should go and look at the video yourself for that. But needless to say, she makes some very, very beautiful things, and the entire channel is a treasure trove. I believe she is now 100% full-time YouTube, and is deservedly so, because the output here is prolific. And yeah, look at that tiny bench. I love that tiny bench. But yes, as I say, if you want to see the finished product, head to the link in the description of the video and enjoy NerdForge. It is a fantastic channel with a bunch of different maker stuff on it. I'm amazed we never featured it on our show before. For our last project before the break, we're returning to Hackaday with another smart home DIY build. This one's a bit different though. Rather than being a singular product that is built into a very nice shell like the Charizard Humidifier, this is an entire hardware framework for an open smart home that does not require an internet connection, something I am quite a fan of. So this is an ESP32 module development board, and it is inside a quite nice 3D printed shell here. These little hexagonal kind of remind me somewhat of beehives for some reason. And as you can see, there's some LEDs in here, and these are some LED strips coming out of it too. This works in tandem with a Raspberry Pi, and those two things are the only things needed for this network to work. In fact, even if the Raspberry Pi stops working, as it mentions here in the Hackaday article, there are redundancies in place to stop the ESP32 acting badly if the network goes down. There is no need for this smart home to attach to the internet in any way unless you want it to. And the stack that has been implemented for this has been completely done from the ground up with that in mind. It's a secure DIY smart home framework. It's a really nice idea. Now, I could wax lyrical about this idea for quite some time, as it's something that I have been very interested in developing myself. I've always wanted to make a completely self-contained, just in-house smart home system. Never really had the time to do it, or at least back when I had the time to do it, I didn't really have the skills to do it. This is a wonderful implementation of that idea. And there is a 10-minute video that is on the Hackaday page here from the creator, giving an update as to where they are now. It's also just a very nice overview of the project in and of itself. And the write-up is also on Hackaday. There's a link out from the Hackaday blog page to the project page on Hackaday as well. So yes, it's definitely worth taking a look at if you are into smart homes but don't necessarily want to buy into a single provider or connect your potentially security hole-ridden consumer smart home devices to the internet. This is definitely worth a look. Before we move on, a little quick housekeeping. Now, if you are enjoying the Electromaker Show, there are a number of things you can do that will really help us. The first is to subscribe to the channel, which shouldn't change your YouTube usership all that much. We're much more likely to show up on your home screen, and of course, we'll show up in your subscriptions, but you won't be getting any notifications from us unless you click this little bell here. Now, if you click all, you will get notifications only within YouTube, unless you set your browser to give you desktop notifications, but why would you do that? That would mean up here where you get the bell, you will get a notification, and here's a notification for last week's show. And the other thing that you can, of course, do is click like. It may seem like a very silly and arbitrary thing to do, but it really does make a difference to our standings, and it will make more people see the show. Electromaker also has a Discord server, and you can find a link to that in the description of each video. And of course, as I say so often, there's no obligation to do so, but if you really do want to support us, the best way you possibly can do so is by heading to the Electromaker shop and buying components for your next projects from there. There really is no better way to support the show, and thank you all so much to the people that have been buying stuff from the shop. It really does make a large difference. Anyhow, that is enough of the self-aggrandizement. No, self-advertisement. Let's get on with the rest of the show. It is time for funding website things, and we find ourselves once again on CrowdSupply. Now, you may remember Quark, because we talked about it briefly a few weeks ago when it was in pre-launch, and as well as being the name of the Ferengi with the best redemption arc, it is also a pocket, oscilloscope, power monitor, and debugger. It does a lot, this little thing. And one of the reasons I wanted to leave it at the time and come back to it later is because I wanted to wait until it launched. And it is now in the funding phase, and you can get your hands on one of these for $150 fully assembled. Now, let's have a quick look at what this actually is. So essentially, Quark is a handheld power monitor and oscilloscope for working with logic level things, PCBs, your own hardware designs, and it uses one of the mainstays of hardware design these days. It uses an ESP32 chip at its core, which means that not only can you use this as a standalone device, as you can see on the side there, it has a USB-C port for charging. Here is the ESP32 module. You can use it as a standalone device, but it also works with a native smartphone app for iOS and Android for logging and for using as a general monitor screen. It's a very nice compact little thing, all fitting together into one unit. So here's a quick look at that PCB again. Now in this image, the screen is flat on the PCB. That folds out when it fits into the handheld thingy that it comes in, that nice ergonomic-y looking shape. And the ESP32 is under there, and of course here's the probe at the front. These three function buttons are supposed to be designed, the swiping buttons are designed to make it easy to switch between all the different things that it can do, whether you're measuring voltage or wanting to plot some serial data from the UART of whatever you're doing. That allows you to switch between everything. And as I mentioned, you don't need to use a smartphone app with this. The idea is that it's a standalone device. Everything will work on the screen. What I haven't read up on yet is how logging works, but I imagine there's some way of logging stuff as well on it. And if not, of course, that's when the smartphone app works. I wonder whether you'd also be able to just pair it with the Bluetooth on a laptop. Given this is an open source thing, I'm sure someone will come up with a way of doing that shortly after this thing is released. So just to whip through it, you can get the voltage and current, and as well as looking like resistor values here. And this is super interesting. You can log and plot UART data. It's essentially a functional tiny oscilloscope. It's also a signal generator, I believe. Auto-detecting things like baud rate across the UART and plotting what's happening across the UART as well. And here is what I was talking about. This is the smartphone app. In fact, when I say smartphone app, there is in fact two, as it says here in the copy. Yes, the first is written in the App Inventor environment, so has two purposes: to help users get started and to acquaint novice developers with the platform. The second is written in Flutter, which is a more feature-full app by the looks of things. So if this is something that might interest you, come and have a look at the page. If you find yourself hands-on with hardware quite a lot, even if you do have a desk oscilloscope or whatever, having a simple hand probe that you can use for a bunch of different tasks might be something that interests you. And the price of $150 is not all that shabby either for what you are getting. This certainly does not look like a throwaway project. This looks like something that has been worked on very carefully for some time, and I'll be interested to see where it goes. So yes, Quark, not just a Ferengi, a fantastic handheld device, and I will leave a link to it in the description of this video. Up next, a breadstick. Now, I am not talking about the bland snack that requires a dip to even be considered a food. I'm talking about a very cool little development board. This is the M4 breadstick, and it is one of the coolest designed evaluation hobby board, whatever you want to call it, for microcontrollers I've seen in ages. Now, this is the SAMD51 chip, so that's a microchip SAMD51. It's in a bunch of Arduino boards, it's in a bunch of Adafruit boards, and therefore it is supported right out of the box by CircuitPython and the Arduino IDE, which is lovely. But the design of the board itself, I just find such an interesting concept. As you can see, it goes just across the central channel of the breadboard, leaving all of this nice real estate for components and working with it. And the pins are all spread out too. So as you can see here, these are all the pins spread out all across the board so that you can work with them in different ways. Now, of course, you're still going to have to use some jumper wires in between, but with this board, you're not going to have to kind of stick two jumper wires right next to each other, and the only two available holes in the breadboard left from your wide evaluation board for whatever you're working with. It's just a really nice concept. Now, also on this board, along here, there are 14 dot star LEDs. And if you're not familiar with dot star LEDs, they're sort of like the less complicated cousin to WS812, B and 11 and NeoPixels, essentially. Whereas the NeoPixel only requires one wire to work, it does require very precise timing. These take two wires, but can work with a bunch more microcontrollers that are way easier to work with in theory. You just need one extra wire. But in this case, it doesn't matter because they're in the board anyway. It's all part of the board. There are 14 dot star LEDs here. There is another one, which is, I believe, this thing here, which is just sort of a user LED for status and all that kind of stuff. Yeah, this is such a wonderful concept for a board. We've seen these very thin little boards. In fact, we featured one on the show a while ago, which is a similar concept, but much smaller again. But something that reaches the entire length of the breadboard, that allows all this real estate for extra componentry and all that kind of stuff is just a really inventive idea. So there are a number of nice features here, but just very quickly, 20 I/O pins, 9 of which are ADCs and 2 of which are digital to analog converters. Music! And there are 24 dot stars, like I've said, 3.3 volt micro USB, and also an SWD interface if you want it. Another nice touch, this potentiometer here, as it says, if it's attached between A1 and A20, it also automatically attaches it to 3.3 volts and ground. Just a very handy and neat way of attaching a potentiometer to a project. Yeah, a lovely idea for a board. Now, this is not out yet, as you can see by the form factor of the page. You can enter your email address here if you're interested in it. I'll leave a link to it in the comments, and we will definitely be coming back to this one at a later date. It is time for us to announce the winners of the Nordic Thingy 91 competition that we started last week. Now, I waxed lyrical about how cool I found this thing, and just before we announce the winner, I just want to bring your attention to something on the Electromaker website that might whet your appetite and make you want to get one of these for yourself. Now, I primarily make the Electromaker Show for Electromaker. It takes up a lot of my time, but I do a few other things around the house as well. And the MakerBoard Spotlight is one of them. These are fairly high-level views of different single-board computers and microcontrollers and all that good stuff. Mostly just what they do, what they are, quite high-level, to see whether you might want to buy them or not to fiddle with them. But when I can, I do actually like to get involved and actually mess with them myself and really understand how they work. And I've been lucky enough to do this with both the Thingy 52, which I didn't write about but have played with, and the Thingy 92, which I have here. And they're both really easy to use. Nordic's tools are fantastic. I unfortunately don't have time to go into that now. However, the article I wanted to show you, not just to show off that I can write as well as speak, but to show you this little PCB. So here is the NRF 9160 system in package. This is the star of the show. This is what is running everything in the background. It's NFC capable, it's GPS capable. Over here is where the SIM card goes, and the SIM card is also included. And the SIM card that comes with it is one that has never been used. I have my own SIM card I use for all of this kind of stuff. And there's also another NRF chip on here, which is the 52840 system on chip, which is just acting as a board controller here, but it's pretty powerful in and of itself. I believe that's the Bluetooth low energy chip that you find in the microbit, but don't quote me on that. Anyway, I wanted to show you this article because it gives a rough overview and shows you various angles of it. It tells you everything that it can do. It also goes into a few of the example projects that Nordic give you to get started, including NRF Pizza, which is fantastic. This is a full project that they've put up on GitHub with an app where you can order a fake pizza, and the Thingy 91 monitors where the pizza is, how hot it is, whether the box has been flipped over, all kinds of good stuff. There's a lot to learn from that project. It's a really... Not many people put such full projects together for their hardware. It's kind of cool. The other reason I wanted to show you this is that this is one of the things that we stock in the Electromaker store, or at least by the time you see this, it will be back in stock. The Thingy 52 is here on the Electromaker storefront. By the time you watch this, if you search for Thingy 91, you will find it here as well. There's never any obligation to buy anything from the store if you watch the show, but it is the most direct way you can support the show absolutely in any way, shape, or form. Anyway, enough of talking about my writing and our shop. Let's choose the winner. So the winner of the Nordic Thingy 91 competition is Mike Deeder, or Deed, if I'm pronouncing that correctly or wrongly. That's sort of what I do. With a project that uses all of the sensors and things that are already built into the Thingy 91, along with the battery power, because the idea is it'll go around with him as he runs around the city, but also adds an air quality sensor to test the quality of the air that he's breathing in while he runs. It's a fantastic project that uses everything the Thingy 91 is great at, and also a really interesting thing. If you do end up putting this together and it works, Mike, I'd be really interested to see how the air quality changes as you run around the city, being a fellow city runner myself. But congratulations, we will be in touch with you as to how we can get this out to you. But one thing I do want to make very, very clear is that there were no bad entries in this competition whatsoever. This was an incredibly difficult one to judge. And some of the ideas in the comment section are not only just nice ideas for hobby projects you could do with this, but ideas that could truly help people's lives and things that I'm really glad that people are thinking about using this kind of technology to develop. So by no means do not think that your project did not have worth, since that you were not picked to win this singular Thingy 91. If I had an entire box of Thingy 91s to be giving away, you would all be getting one for sure. We're going to finish the show with a few product updates and cool things and news and anything that doesn't fit into the other parts of the show. And we're beginning this week with Mouser. Now, I am no stranger to Mouser's media output. In fact, if you're a subscriber of the Mouser YouTube channel as well as this channel, you may notice a relatively familiar voice occasionally doing some voiceover for them. However, I was not familiar with the Electronic Information Update magazine, amazingly, and someone sent it to me this week saying it might be a good thing to feature on the show, and they were right. Now, this really is a fully fledged magazine. There's a lot going on in here. And this particular issue is all about edge computing. So artificial intelligence on the hardware edge, embedded AI, and as we know from the show, AI can go down to anything as little as an Arduino these days with a tiny ML library, right up to your more powerhouse boards like the Jetson Xavier. This is all about how these things can work at the edge, but it also has things like regular news sections and what's going on in the industry. One thing I found particularly interesting was this one about skin patches, smart skin patches for monitoring patients. We've actually talked about things like this on the show not all that long ago in terms of research for new ways for monitoring movement and temperature and heart rate on people's bodies using non-invasive simple patches that you could stick on that weren't exactly throwaway but weren't quite as fragile and hard to attach as other medical equipment might be. The kind of thing that you could literally stick on someone's arm and then you wouldn't have to necessarily go and visit them every time you wanted to do something as simple as check their temperature or heart rate over time. So here's an article talking about a time when we have all been very separate and how that has pushed this kind of technology forward, with a link to more information if you would like to see it. Something that I find just really nice. I wish old magazines had that. I wish I could just click old magazines and it would open up a page with more information. So I don't have the time to go into much more detail. Needless to say, I found this to be a quite interesting read, and I'm actually quite a fan of digital magazines as an art form in general. Digital magazines and zines are a nice way of reading things which are a little bit separated from your normal blog structure or finding stuff on social media and all that kind of stuff. I found this actually quite a nice thing to flick back and forward through the pages, and the content itself is really interesting too, especially this how to build your own voice assistant. This is using an Infineon Relax evaluation board, which is the XMC 4700 Relax. These are really nice little boards, which are surprisingly Arduino IDE compatible. I had no idea. Yes, really interesting project. If I had one of the boards, I'd be having a go at it myself. And a generally interesting magazine I did not know existed until this week, so I will leave a link to it in the description of this video. Now, here at Electromaker, we are big fans of contests. That's why we have contests on the show every week, and we have big contests on the website that last for months, which is why I'm so glad that Arduino are putting on a contest that's not only interesting, but important. The PCBeTheChange challenge is something that Arduino is doing in partnership with Altium and the IPC Education Foundation. Now, this is based around an environmental focus. It's innovation for environmental change is the tagline. The idea being that the students, as it says here, will be challenged to tackle one or more environmental concerns such as air pollution, water quality, and solar energy capture. And they'll be doing that using the hardware Arduino are providing. That is the Portenta H7, that's the super powerful STM32-based Arduino board, and then a variety of sensors and things attached to it. Presumably that they will also be designing themselves, because that's where Altium comes into it. The Upverter modular PCB design software, which looks super powerful. I've never had my hands on it or even heard all that much about it until now. And reading it up, it does look very, very cool indeed. But yes, that's also part of the project. The students will be using that to make their designs. And it is a contest much like we have on the Electromaker website. You get sent out the hardware, you do your project, and then there are cash prizes, namely $1,500 for the winner, $750 for second, and $500 for third. So this is aimed mostly at high schools and colleges. If you are interested in being involved, there is a registration period that runs right through until Friday, the 1st of October, and this link is on the Arduino blog, and I will link that Arduino blog in the description of this video. Finally, something absolutely baffling to me. This is Linux running on a simulation of a RISC-V chip, and that simulation is running on a graphics shader. Yeah, that's as crazy as it sounds. Now, this is a blog on the Adafruit website, and I'll leave a link to this blog for a couple of reasons. Firstly, the original Twitter thread is linked from this page, and from here is where you can actually find the GitHub account. There's a link to it right here. And so that if you are someone who uses VRChat and you just want to check this out for yourself, there's a link to the world right here. All I'm going to do, instead of talk about this anymore, is just play a few seconds of the VRChat community meetup where this was revealed so you can hear the absolute hype that this caused.
Behind this curtain.
Please, okay. Please tell me this is done in a shader. Please tell me this is in a shader.
Kernel version 5.13.5, running in a shader, about 5 to 6,000 lines of H&S of code.
Oh, wow. So, let's end with the on the neck right now.
So, Linux running on a RISC-V simulation within a shader that runs in VRChat. That's just wild on so many levels. And they ported MicroPython to it as well. Just a wonderful project. And yeah, as I say, you can find everything you need from this one Adafruit article, which is the one I will link in the description of the video. So that was our show for this week. Thank you so very much for joining me. I hope the audio quality was okay this week. I may or may not have mentioned it during the show, but we have a very shiny new microphone after my old microphone started doing a slow electrical death sounding thing last week. So if the audio was a bit off this week, if there's anything that should go up or down, please do tell me in the comments. I think I may have got it sort of balanced, but it is all very new. Anyway, the most important thing for me, as always, is that you have a safe and fun week, and I hope you work on something cool. I'll see you next time.